All right, I wanted to give a little update on some of the features I added to my little prototype building projectional web editors with Elm. One thing you might see right away is that the transitions now feature nice arrowheads and that these arrowheads align nicely with the edge of a node. It was kind of funny to do this whole trigonometry stuff again after so many years. I think the last time I had to do something like that was back in school, but I'm quite happy with the result. I think it turned out nice. Anyways, another thing I wanted to add, of course, is that nodes can contain arbitrary editors, because before it was only possible to have exactly one input field, and that was not very flexible if you want to build a little bit more involved nodes. So I wanted to do a little demo of how we can enhance this example with some more content inside the nodes. And this is my professional way of preparing the targeted UI. Instead of just seeing the input field, I also want to give some information about incoming and outgoing transitions. So let's dive into the code and try to add that to our graph. So here we are in the state machine module, which is our Elm module that contains all the domain-specific information about our state machine language. And we want to update the editor for the Vertex. So we go to the editor of the state machine, and remember that we have this split screen here with stuff on the left side and stuff on the right side. And of course, our graph is on the right side. And we want to update the editor for the vertices. So currently, we just iterate over the default children of a state machine, which are the states, and map these over the editor state vertex function. So each state gets passed to the function here, and we create a vertex cell, which looks a little bit different maybe than the last time you might have seen it, but not more complex. It's just a vertex cell needs the name because we use the names in order to be able to draw or render the transitions correctly. And then we just say, okay, this vertex cell currently also has a input cell as content. So instead of just having a input cell, we actually want to have a stack. So let's have a vertical stack cell here, and this vertical stack cell now has an input field. So we just wrapped our input cell with a vertical stack cell, so we are able to add more. So the input cell should be on top, so that's just fine. And below that, we want to have some more information. And more specifically, we want to have something horizontally stacked. So we use a horizontal stack cell, and we add a constant cell first, just to try it out, and say incoming. Incoming. Okay, format that nicely, and just going to build it real quick, and then go back here, press F5, and as we can see, this added a constant which is by default styled like a keyword. We don't have configuration for styling yet, but that doesn't worry us too much. It's nice to see that below our input field, we now actually see this constant here that we wanted to add. So this is good. Let's just add a second row by copying this code and format it nicely and say outgoing. Outgoing. So now I have 3 children in my vertical stack, our input cell, then a horizontal stack, which currently just has a constant cell, and another horizontal stack that also has just one cell. Compiled. Okay. hit F5. Okay, looks nice. So a state itself knows how many outgoing transitions it has. So let's start with the outgoing. We have a horizontal stack here. We want to have the outgoing, and after that on the right, because it's a horizontal stack, it will be put on the right. We want to have another constant. And here we basically want to have an editor for the number of outgoing transitions. And I could inline that here and basically say, well, give me the length of what you have under your default trait or under your default feature, your state. This currently is not 100% correct because the constant cell wants a type of string, and list length returns type of int. So we just add string from int, and we have all these parentheses, which isn't very nice, but let's just see if it works that way. Okay, we see a number, and it looks like this number is correct. So idle has one outgoing transition to active, active has two outgoing transitions, and waiting for light, waiting for dry is one outgoing. So it works nicely, but the code is starting to feel a little bit weird with all these parentheses. So instead, let's use a let expression where we calculate the number of outgoing transitions. And let's just put that here and use the pipe operator to avoid all these parentheses. And here we can just say num of outgoing transitions. So this should be fine now. Let's just see if it still works. Yeah. Okay, so we have the same behavior than before, but we just factored out this little function or this little value, so we don't have it inline here. Okay, so now let's add the number of incoming transitions. So basically what we want to have is something similar here, but of course we want to have the incoming transitions here as a value. Now, a state itself doesn't know who's referencing it, so we need some more context. So we need to enhance our function so that it also takes a state machine. So we pass the state machine every time we map over the states. So that's good. And now we need to add our num of incoming transitions value and basically say, well, give me all the nodes of type transition that you contain in your state machine. So we just look locally. Then we say we filter this list of transitions by means of names that match our state name. So we ask our domain-specific role state ref under the transition if it equals the name of our state. And then we can ask how many did you find and get the string value. So now this number should carry the number of incoming transitions. Let's see if that's right. Yeah, looking good. Idle doesn't have any incoming transitions, whereas active has one, and unlock panel, for example, has two. Okay, so that looks nice, but as you can see, our graph doesn't look as nice anymore in terms of seeing the transitions. So another feature I added is having control over the gravity center and, well, not the center at the moment, but the gravity strength. So pressing the Shift key shows me this little circle, which I can now, using the mouse wheel, increase and decrease, and thus changing the gravity force applied in our little graph. We can also see the gravity strength. It's just a unitless number at the moment, but it just indicates at least a little bit what's going on. I want to add the ability to drag and drop the gravity center as well, which is currently not possible. And I also want to add a mode where we can change the viewport of a graph. So we can zoom in and zoom out a little bit more, or at all, because currently that's not possible. But yeah, that were the features I wanted to share. Was quite a lengthy video in the end. So thanks for watching. And one request I have is I also would like to try and build other languages, not just state machine languages. So if you have any ideas what kind of language you would like to build, just let me know. I mean, you can try it out yourself, but it would be great to get more inspiration with regards to the languages I work on, because the features for the projectional workbench itself basically derive currently from the examples I have. So the more examples I have, the better the features will become, I'm sure of it. So again, thanks for watching, and looking forward to hear some suggestions regarding languages I can build.